Do it when you do the extra credit with me. So, so remember, you guys are coming in. You're going to be coming into my office hours to say, hey, I've got some extra credit. You know, here's all of my handouts. So give me extra credit for this. And when you do that, when you come to my office hours to do that, also tell me about, you know, if you're in Tier 2C or if you're in Tier 2C or 200C, 201C, those ones. Does that make sense? Okay. Great. All right, so let's go ahead and take a look at these ones here. Again, we are looking at a claim of not equal to if they differ, right? So since we're looking at their differ, then my claim is going to be that mu1 is not equal to mu2, and it's an average, so it's mean Mr. T. We're going to be using the T distribution. So my H0 is going to be always, always, always equals, mu1 equals mu2, which means my claim will have to be H1. mu1 is not equal to mu2. So again, I'm looking to support or not support my claim. That's what's going to be. That's the word that's going to be going down into step 5. My critical value, degrees of freedom, n-1. So the smaller between, I have 8 female infants and 10 male. So I'm going to take the smaller one, 8. 8 minus 1 is 7. So this is not equal to. So because it's not equal to, everybody see this part here? My claim was differs, which makes my claim not equal to, which makes this a two-tailed. That's how we get the two-tailed. You got to look at the claim. The claim is differs, different. So that's going to be, different means less than or greater than, either one. So two-tailed. So it's going to be a two-tailed, degrees of freedom 7, alpha is 0.05. So pop out your T-table, and you're looking at two-tailed test, 0.05, degrees of freedom 7, so that's going to be 2.365 right there. 2.365, positive, negative. 2.365, positive, negative. And then we're going to do our stat test. So, oops. So X bar 1, let's see, that was 123 ounces. And X bar 2, 116 ounces. So my numerator is going to be 7. And the denominator is going to be S1, 8 ounces divided by N1. S1 squared, 8 squared divided by 10, N1. And then S2 squared, which is 5, divided by N2, which is 8. So 5 squared over 8. And if you add those, if you square that and divide by 10, and then add it to this one squared divided by 10, you're going to get 9.525 down below, which I think ends up being just over 3. 7 divided by 3.1 or something like that. Anyway, you end up getting 2.268 here. So 2.268 is my test stat. It's definitely in this not guilty range, just barely, but it is in the not guilty range. So this is do not reject, not enough evidence. So we are not going to reject. We're not going to reject H0, which means we do not have enough evidence. Those two go hand in hand. 2, and then because my claim was differs, my claim is H1. So it's going to be support there. The claim that average weights of baby boys differ from baby girls. Now, if my claim was that they're the same, if I claim that newborn infants are the same as females, then my claim would be H0. And then I'd be using the word reject. And my claim would be, claim that blah, 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 blah is the same as baby girls. So if my claim was the same, then I'd be using reject there and reject that they're the same. Does that make sense to folks? Do you guys have questions about that? My other classes were a little...
Professor Young?
Yeah.
One thing that's a little confusing to me from an interpretation standpoint is if we had simply asked the question, if we had simply made the claim, rather, that the mean weight of newborn boys or males is larger than the weight of newborn females, then it would be a one-tailed test.
It would be.
And then we would conclude that there is enough evidence to support the claim
right.
that the average weight of baby boys is larger. So
yeah.
how can we now concluding that it's not different?
Because that wasn't people's claim. What they're claiming is that they're different. The researcher wants to know if they're different. He doesn't want to know if the boys are larger than the girls. That would change things. Absolutely, you're right. So if you're going to do that, if you're going to say that they're larger, then maybe you might make the alpha 0.025 and change that. But yeah, you're right. I mean, whether it's different is kind of in a way tougher to prove than larger or less than, because it makes all your alpha becomes in one tail instead of two tails. But you know, it's what the researcher wants to know. If the researcher wanted to know larger, then we'd use larger. If the researcher wants to know different, then we use different. You have to do whatever your research is. And you raised an excellent point, which is that if it's one-tailed, then all your alpha goes into one tail, and this area becomes large. Your critical value your area would kind of include this space here, so your critical value would become closer to the middle. But it is what it is. Right? It depends upon what you're claiming. Yeah, it's a very good observation. And that's why it's really important that you have to stick with verbatim what the claim is, because it's all about what the claim is, what they're claiming. And that's what it all starts from. So, if you're trying to cause false positives, then you probably want to do a greater than or less than. You probably don't want to do a two-tailed. All right, anyway, so any other questions about this do people have before we move on? Now's a great time to ask questions. Okay, so now we're going to get into 9.4. So we're skipping page, in your notes, page 26, which is the confidence intervals. We're just going to skip that one. So that would be this page here. Confidence interval estimate. We're just skip that right out. We're not doing it. So just cross an X through it, skip it, move on. And then we're going to hop into this one here. So this is what we're working on. This page right here, everybody should be on it. And I'm going to go ahead and close it down. And we'll do it. Okay. Yep. Page 26. Just one big X. Don't spend a lot of time crossing it out. Just cross, move on. All right. Austin, do you want to go and read this one for us?
Yeah. 9.4 dependent samples. Example, match pairs of height of U.S. presidents and height of their main opponents. Since there is a relationship as a basis for matching the pairs of data, this data consists of dependent samples.
Perfect. This section is super, super easy. It's going to be like the easiest of all of Chapter 9. You just have to pay attention for the next 2 or 3 minutes, because all it is this one little extra step, and it's all just a super, it's really not hard at all. Okay, the hardest part of this is realizing that it is dependent. How do you know it's dependent? This stuff will occur in matched up pairs. So you guys see like these guys are all matched up, where this one goes with this one, that one goes with that one goes with this one, 180 goes with 180, 179 goes with 178. Can you guys kind of see that on your papers? Those are matched up. They are linked together. So it's the height of a president, so this would be Obama. It can't be Gore over here. It has to be whoever Obama beat. If this one's Trump, it has to be Hillary Clinton here. It can't be, somebody else, McKinley or somebody else who lost, right? It has to be the person that they beat. So these are locked in and matched up together. So once you recognize that they're, and you'll see them, that's the only stuff I give you where they're kind of matched up together like this. And they're the same thing. They're both heights. Right? Height of the president, height of the main. There's only one variable still. It's still height. It's just they're matched up. Then it's really easy. All you do is you subtract them. So 189 minus 170, 19. Subtract these, negative 12. Subtract those, 8. Subtract those, 0. Subtract those, you get 1. Then all you're doing is a one sample t-test on these numbers here. Piece of cake. Really, really, really straightforward. And we call these the differences. So these are little d's. These are the differences between your first sample and your second sample. You just take the difference between them, and those are our little d's. Okay, so here's some quick notation for you. D is equal to, they're the individual differences between the two values. The mu D is the population mean of all, theoretically, all total differences out there, that past and present and future. So if you knew of like every possible future president and the person they beat and the difference between them, that would be, you know, you took the average of all those, that would be your mu D. X bar D. So you guys have it as D bar. You can also think of it as X bar D. It's basically, it's your sample, it's your sample mean. It's your X bar, it's your sample mean of your differences though. So the sample mean of those little differences. So if you took all those little D's that we calculated, right up here, if you took all these guys and you found their sample mean, this is a sample, took the mean of them, then that would be your X bar D or your D bar. You can call it either one. And then SD would be the standard deviation of those, and N is the number of them. How many pairs did you have? Right, in this case I'd have 1, 2, 3, 4, 5. 5 of these. That's my N. Okay. Basic requirements. The sample data are dependent. In other words, they're matched up, these little pairs. They're simple random samples, and either you have a sample size of 30 or more, or they are approximately normal. Ours are always going to be approximately normal. All right, so the only other step again that changes, which is kind of the same as Chapter 8, it's your D bar, in other words, your X bar sub D, your X bar of the D's, minus your mu, which is, again, the same thing you have in your claim. So remember, this first one, the X bar, that's from your sample. It's your sample mean, whatever you got in the sample. And this mu is going to be whatever is in the claim. And then over S over square root of N. So that's pretty much the same as we had before, degrees of freedom, N minus 1. So this is the same as Chapter 8. The next part here, you're going to skip this little tiny bit right here in the middle of the page where it says confidence interval for dependent samples. We are not going to cover that this semester. That's part of the stuff we're cutting out. So you can either cross that out or just put skip or whatever. Just realize you don't need to know that for the exam. And then now we're going to go through this example here at the bottom of the page. So that's what we're going to do now. So you guys need to write in the differences, subtract all these, and write in the differences right in here into those boxes. All right, so we're going to subtract all those. So do that. You guys written these numbers in those boxes yet?
Yeah.
Okay. So, great, thank you. Okay, perfect. So now we're going to look at the claim. The claim is the heights of the presidents, these differences. So if you take the president and subtract their opponent, mu1 minus mu2, the differences are going to be greater than 0. So remember back when I told you guys, hey, don't forget, you know, back here, right, how you can also, instead of writing it P1 equals P2 for your H0, you can write it as P1 minus P2 equals 0. That's what we're doing here. We're saying that mu1 minus mu2, in other words, our mu d, because remember our mu d is mu1 minus mu2, is equal to 0. That is our H0 for this one. It's going to be the differences. mu1 minus mu2 equals 0. So in other words, mu d equals 0. That's our H0 for these ones. That's the claim always for our 9.4. There are some cases in the world where it's not 0, but for vast majority of them are 0, and that's the only one we're going to cover in this class. So now, what we said in our claim was that the presidents were greater than their opponents. So in other words, mu1 is greater than mu2. So if I subtract them, then the difference is greater than 0. mu1 is, this would be, if you subtracted them, you'd end up with a number greater than 0. So that's my H1. So you should be writing this down. Step 1, H0 is mu d equals 0. H1 is mu D is greater than 0. In other words, the first one is greater than the second one. So the difference is positive. And this will match up with whatever you had for mu1. If mu1 is less than mu2, then this would be less than 0. Okay. Step 2. Okay, let's see what we have. We've got 1, 2, 3, 4, 5 matched pairs. So my degrees of freedom is going to be 5 minus 1, which is 4. And my alpha was 0.05, and it's one-tailed, greater than. Right? So we know this is greater than because we said, literally said, the differences will be greater than. So the population of the president is greater than their opponent. So greater than means it's going to be right-tailed, which means it's going to be one-tailed. One-tailed, right-tailed. So if we go down here, right-tailed, one-tailed, alpha is 0.05, degrees of freedom 4. And it's a mean. Right? These are numbers. My data is numbers, so these are means. So I'm going to go to my handy-dandy t-table. One-tailed, 0.05, degrees of freedom 4, 2.132. Right there. 2.132. That's my critical value. And it's positive because it's right-tailed. So I'm going to shade to the right. Draw a picture. So you guys all have your picture in here with the critical value. Don't put your test set in yet. Just do your picture, critical value, shade. And then step 3. Okay, so we got to figure out what our, let's go back here. Let's figure out what our mean is. So you're going to get stuff, this one and probably one other one, where you need to find your mean and standard deviation on your own. So here, let's see. I've got, I'm going to go to Stat, Edit, and here's my little list. I'm going to put them in there. So they were 19, negative 12. Remember, negative 12, you can't use, don't use the subtraction symbol. Everybody bust out your TI calculators. Don't use the subtraction symbol. You have to use this negative sign down here, negative 12. Oops, too far. 8, 0, 1. So now double check and make sure you got them all correct. Is that 19? 19, negative 12, 0, 1, good. Okay, so here we go. Now we're going to do Stat, Calc, 1 var stats. So it looks like you kind of really do need to have a calculator, or at least a Texas Instrument that can, or a Casio that can do these list things. And I want to do list 1. My stuff is in list 1. So second 1, that gives me the L1. You can see the L1 right there. Enter, and that gives you my X bar, 3.2, and my S. Remember, we know it's a sample, so sample standard deviation 11.4. 3 sig, we'll run to 3 sig figs, that's good. 11.4. Okay, so here we've got my X bar D is 3.2. My S is 11.4. I'm going to pop those in. Remember, this part here is my sample, 3.2 from my sample. This is from my claim. My claim was UD is equal to 0. So 0 goes there. Over S over square root of N, I had 5 items. And you get 0.1628. So pop that in here. I'm going to draw that in. So what do you guys think? We're going to reject or not reject? Okay, good. We're not going to reject. Yep, do not reject H0. It's in the non-guilty area. So we're not going to reject it. Do not reject H0. So that means we do not have sufficient evidence. 2, support, because again, H1 is my claim, so whenever H1 is my claim, I use the word support here. Because rejecting H0 supports my claim. So that's why we're doing the whole test to reject or not reject H0. So when I reject H0, that affects my claim because rejecting H0 supports my claim, so I'll use the word support here always. Always whenever H1 is my claim, because rejecting H0 always supports my claim. The claim that the population of presidents and the opponent, the differences have a mean greater than 0 centimeters. Okay. Do you guys want to spend just 10 minutes going through? Do you guys have any questions about this first?
Can you go back to the last slide real quick? This one, don't get my numbers.
Yeah, this one here? Okay, so I'm going to do is I'm going to give you guys 9 minutes to go through this with your groups and try to work on your next problem, which is problem on the next page, problem number 6. And we won't necessarily finish that. We'll go through it, and again, next class. The other classes did not get to it, but I think if we go through this, then that'll give us more time to prep for the exam next class, and I'd like to have you guys do that. So take a look at this one. The first one is just the numbers that just kind of help you, keep track of them all and realize it's the first person, second person, third person, fourth person.